Hi everyone. We're going to have a look at constant acceleration in this lesson. So this lesson is all about how we relate together distances and velocities and accelerations. Normally if we know enough things we can figure out everything about the motion, how fast it started, how fast it finished, how far it's traveled, how long it took and what the acceleration was. So this is what we're going to cover. We'll go over something called SUVAT. You may have heard this before if you've covered it in lessons, but we'll go over what it is. It's an acronym for 5 things we tend to look at in constant acceleration problems. We'll have a look at the constant acceleration equations. These are all actually given to you in the formula book, but it's just going over how we actually use them. We'll have a look at a systematic way of solving constant acceleration questions. We'll do a load of examples, both horizontally and vertically. So the vertical questions involve gravity. Gravity provides a constant acceleration, so we use the constant acceleration equations to solve them. And we'll finish off with a practice question as well. So let's start with SUVAT. It is an acronym with 5 letters. S, weirdly, stands for displacement. Okay, so it's just a it doesn't stand for displacement, obviously. It's just a convention, really, that we use S for displacement because D is normally used for other things like differentiation. U is the initial velocity, so that's the velocity at the start of our motion. Normally we measure it over a set period with a start point and end point, and U is the initial velocity it has as it passes the start point. V, on the other hand, is the final velocity. That's the velocity it has as it passes the end point. A is the acceleration during the motion, how much the object is accelerating or decelerating. If we've got a deceleration, A will be negative. And T is the time that elapses during the motion. So we can kind of represent it something like this. So we've got a start point here, an end point down here. Between those 2 points, we've got an acceleration A, and it takes a time T and covers a displacement S as it goes from this start point to the end point. Basically, if we know 3 of these 5 things, we can work out the other 2. So we only need 3 to sort of finalize the problem and use our equations to get the other 2 variables. Notice that A is a constant. We have to have constant acceleration for these equations to work. So that means it can't be any kind of varying acceleration. So on a velocity time graph, we have to have a straight line. So if we have a straight line like that, then we've got constant acceleration. Okay, if we've got constant acceleration, we can use all these equations and it makes our lives quite easy. If we haven't got constant acceleration, we'll need an equation to model it, and we'll cover that in the next lesson on calculus. So let's have a quick look at the constant acceleration equations. Each of them contains 4 of the 5 variables. Remember, we've got S, U, V, A, and T, hence SUVAT. Each of them has 4 of the 5 variables in, so each of them is missing 1. And all of these are given to us in the formula book, so you don't have to worry about memorizing any of them. The main challenge for us is figuring out which one we actually need to use to work out the answer to a question, okay? So don't worry about memorizing. Just worry about choosing which equation we need for the particular question we're looking at.